Okay, so hello, good evening, everyone. Our discussion for today is on how to make a program. I- Um, this is solving linear equations using Gauss-Jordan Elimination method. Okay, so on what is the this is just an overview on what is Gauss-Jordan Elimination method. This is a method of solving linear equations system of I mean so a method of solving a linear equations system of linear equations. This is done by transforming the system augmented matrix into reduced row echelon form by means of row operations. So here in our left, as you can see, this is the process on doing the Gauss-Jordan elimination method. Okay, then since my topic is not on how to use the Gauss-Jordan elimination method, but rather on how to make a program using the algorithm from Gauss-Jordan elimination. Okay, so before we go to our code, let me show you a short overview on the finished program that I have prepared. So here, we have two windows that is very important. That is, first is our input data. Here in the input data, we have the 10 by 10, 9 up to 2, which is two equation, two unknowns. So in this window, you are required to input your data. So for example, you have a 10 equation, 10 unknowns. So all you need to do is to input it here in this fillable cells. Okay, so this is colored according to its number of equations and unknowns. Then for my example later, I have inputted a 10 by 10 and also here a 3 by 3 3 by 3 unknowns. Okay, so on how to operate this input data, I have included it here. Okay, so it's very clear that we are in input data, so that is here. Then please take note that the variables are presented in A, B, C up to G. Okay? Then and so on. And you can notice it here. Now you might also asking what is the default for this one. Okay, so this default this is clickable. Okay, so for example, we have inputted data 1 2. Okay, and somewhere in this cells, then you want to delete or change this data because you do not want this one, or you want to change the data. Okay, so the easiest way is to click default. That is, the value will change to 0. Okay, so that's the purpose of the default click. Okay, so after you have inputted your data here in input data, so you are go to your result data. So in result data here, first things first is to select the number of equations. Okay, so in our example, which I have already inputted, which is the 10 by 10. If we select 4, which is I do not have an input there, so it will show you 0. For 3, I have inputted 3, so here it will show. Then for other one, 8, I don't have input there, so let's use 10. Okay, or first is 3, number 3. So let's click clear before running your program. Okay, so always click clear first, then after that click run, then this is your answer. Okay, then how about you have inputted the 10 by 10, so here, then click clear first so that it will not overlap the data, output data, and then click run, so this is the answer. Okay, so here I have a notes on how to operate the result data. I think this is just easy to understand, and here please take note that this program, the limitation of this program is up to 10 by 10 only. So 10 equations, 10 unknowns only. Okay, then the program will not solve or will notify you error message if you haven't done inputting your data. So for example, you have not input data here. So this is 0. Then suddenly you click run. Okay, so for example, let's select 7. So no data. So it will show you 0. Then we click run, so it will show you an error message. This means that you have not inputted data first. That's the problem. Okay, so make it sure that we have done inputting our data there. Okay, so that's how our program works. Now, on how to make this code in VBA, the Visual Basic. Okay, on how to make this possible. So here I have the workflow. Okay, so the workflow is this is for the VBA only, not including on the input data, now to and the other one, which is VLOOKUP command, also the concatenate command, so not included it here. This is purely on how to make loops and using Gauss-Jordan method. Okay, so here first is that we define base dimension. So here, this is, I just take screenshot, but we can go to our developer command, which is the excuse me, so the the module which I have prepared. So here, the option base 1, then option explicit. So we define it here first. The dimension is of course the we select 10 by 10, and the highest one is 10. Then that is 10 row and 11 columns. Okay, and a single means the data that can be read is up to, I forgot, but this is just limited to, I mean, short decimal at to 38, negative, positive 38. I think I just forgot it. Okay, so that is we can also set double, but I guess double is does not applicability here. So I use single command. Okay, so dimension as single. Then as integer for I, j, and k. Then dimension as factor as a single. This is based on the number of decimal places that he can he can still read. Okay, then here the sub command or the module that we are going to use is sub Gauss-Jordan. Then the number of equation is here. This one is linked to our result data. Okay, so this one is linked to our result data. Let's go back to our result data. So here, as you can see, this is C3. Okay, and you can notice it here that n value is equals to the range this cell C3, which is here. You can notice it here. Then also that is means that value. Then the dimension array is that this one states that the size of our matrix. So here, the maximum size of our matrix is 10 by 11. Okay, it's 10 by 11. Then that is 10 rows, 11 columns. Then for our input values, so let's go back to our workflow. Okay, so that is how the number of equations and array dimensions and your input values. Okay, so to point out where your input value is on that present worksheet, so I have prepared this command, which is for I 1 to n and for j 1 to n plus 1 when n is 10. Okay, so 1 to 10 and j 1 to 11. Okay, then for aij, he will read on cells on active sheets 4 plus I. So let's go to our result data again for this command. So here this one. cells 4 plus I. So where is that? This is row row matrix. So this is an row matrix. 4 plus I. So when I is 1, so it is here. Then J, which is 9 plus J. When J is 1, so it is in 10. So you need count this one starting from here. So this is 10. Okay, so this is 510. Then he will read this data up to 10. So here when n is 10 and j is 11 up to here. Okay, then after that we already define our metrics. Okay, augmented metrics, we already defined that. Then next is next on located next on locating our input data is that we perform forward elimination. Okay, so the steps on making a forward elimination is that um, I have prepared it here, the steps on how to make the forward elimination. So our example is 10 by 10 10 by 10 metrics. So that is 10 equation 10 unknowns, sorry. So another example that is 10 equation 10 unknowns. So when when we use this command for k from 1 to 1, and for Ri is equal to k plus 1 to n. So when k is 1, then Ri is on second row. Okay, so this is our second row. Then for solving the factor, that is the second row over the first row on first column. So that is negative 1 over 4. So it is presented it here on second row first column. So negative 1 over 4. So this is our factor. Then we will eliminate, or even we will make 0 on second row first column all values. Okay, so from starting from second row up to 10th row on first column, so this one we will make this column equal to 0, but not including on the first row, that the code is presented it here. So this one, this is aij is equals to aij minus factor times akj. So as you can see, aij, this is the new value of aij, and this is the old one minus the factor times akj. So how to do that is that I presented it here. So for second row first column, or on our matrix A21, so it is here. Then as you can see in our data, so this is our data, on the second row first column, that is negative 1. Okay, so that is negative 1 minus the factor, which is negative 1/4. Okay, so that is minus times negative 1/4 times the akj. Okay, so here, sorry, wait, not clear. Okay, so that's one. So akj, where is that akj? The akj is that this is always on the first row. Okay, this is always on the first row. For the second row, okay, for if we want to take the if we want to make 0 on the second row, so this is this one is always on the first row. So that is negative 1 minus negative 1/4 times 4. So it will lead you 0. Then on the second row, on the on the second column on the second row, so where's that? This one. So this computation. So here this is 3.5. As you can see, this is 3.5. to get this 3.5, the process is that um, the new value, which is equal to 3.5, is equal to the old one, which is 3 minus the factor, which is the factor for the second row is negative 1/4, times the first row second column, so that is equal to 2. So here, okay, so then the value on that one is 3.5. Now if we continue that one, here the negative 3.25, this is the new value on row 2. So from previously negative 4, okay, then minus the factor, which is negative 1/4, times the row 1 column 3, I mean first row second third column, which is equal to 3, then it will give you negative 3.25. Now if we continue the process, okay, so the code will do that for you. So it will solve all here, it will change all values in row 2. Okay, then it will continue, no, for it will continue from since we are still in k2 to n. So when from the start 2, then the next is 3, since to n, since our code here is k plus 1 to n, therefore the code will loop from the start of 2, 3, 4, 5 up to 10. Okay, then it will loop the process up to this this data. So this, after running this one, then we get this this result. So let me show you that one. Okay, so on our command. Okay, so let's go to our result data. So we are on 10 by 10. Wait. Okay, so here I have that. Sorry. Hi. Sorry. Just okay. Sorry for the delay. Okay, so let's no. So let us edit the command developer tab. Then let's go to our new module, which is Jordan 2 for that this command, for that command. So let's erase this one, backward elimination. Okay, so we are on the process of forward elimination. Okay, so when k is 1 to 1, okay, when 1 to 1, then we run this program. As you can see, this is the result, which I have screenshotted it there. Okay, so in our this one, okay, then this is the result. If we continue the process, okay, the loop of that result, then when k is 1 to 2, is that we define 1 to 2 is that from 1, the data from 1 will be used in the data when k is 2. Okay, because if we use just 2 to 2, then it will read on the previous data, which is we didn't done it first, reducing on the second row. Okay, so let's try to see if we're true. Okay, so let me clear it first, then let's run. Okay, so here, as you can see, there is no 0 here, which is, this one is wrong, because we are the previous one is not used, which is not stated in our command, which is 2 to 2. The loop is not including in the first second row. Okay, the reduction on the first, the reduction of the second row, which is not included. Okay, so we should include for 1 to 2. Okay, then the program works. Okay, Next is that here the third one, okay, 1 to 3. If we just continue the process, then our target is that we need to arrive our equation here, okay, this form, okay, which is also I have presented it here. Okay, but what we have done is just the bottom, okay, and the upper is we need also to reach this form, okay, identity matrix 1 1 1, but the upper is 0 and the lower is 0, so we need to arrive this process, okay, we need to arrive this result, okay. So here in we have done in our forward elimination. Next is we will go to our backward substitution, I mean backward elimination. So here, okay, sorry, not just no. Okay, so here, let me make this one clear. Okay, so after reaching our goal, which is 0 in here in this, we already reduce the matrix, the augmented matrix, in this form to 0. Now we want the other side to be 0 also, okay, we want the upper side to be 0. So what we're going to do is to make a code for a backward elimination, okay. So since backward elimination, we have to start from n up to 1, okay. So here, as you can see, k is equal to n to n. This is the first one, which is n to n, but let's go to our code, sorry. So let's go to our code. Let me n minus 1, okay. So sorry, here we are on space this one there. Okay, so this is the process on this is the code on performing the backward elimination, okay. So first is that we try to make this column to be 0, but not this one. So this is from ninth row and 10th column, okay. So the process is that solving the factor, same again, okay, but we're just reversing the process, okay. So for k n to n, so here, then our I or our row row matrix is that k minus 1, okay, k minus 1 to 1 pasabot, what I mean is that it's clearly that is from when k is 10, so minus 1, this is 9, okay, this is on 9th row up to first row, okay. Then the step is 1, okay, so that is 8 7 6 up to 1. Then the factor is that a I k over a k k. So when k is 10, so this is 9, okay. So on a9 10, so on 9th row 10th column over 10th row 10th column. So what is that? From our previous data, okay, from the finish on a backward, we need to, from the finish of forward, we need to perform the step 1 for the backward, okay. So that is negative, so here negative 54, as you can see, negative 54.70, positive 54.73 over negative 26.78. So this is our factor. Now let's make this one 0. So a9 10, okay. So on our augmented matrix, 9th row 10th column minus the factor times the augmented matrix at 10th row 10th column. So here 54.78 73 minus the factor, which is 54.73 over negative 26.78 times negative, so it will become 0. Okay, then I want to solve it here. So this one, since we are to perform it on all columns, so here this is for j1 to n, so it will perform it on all columns. So as you can see on 10th, I mean on 11th row, I mean 11th column, sorry, on 11th column, negative 267. Okay, so let me paste another one here for that process. Okay, wait. So we are on ninth row, 11th column, so 9 11 here. Then this is the old one, 9 11. The factor is just the same. Then the this one is that this is on 10th row, 11th column. Sorry, that one. Okay, so okay, let's continue. Then this one, negative. Okay, so this one is negative 2 to 67.74, minus, okay, minus 54.73. No, not 54.73. Yes, 54.73 over negative 26.78 times the 16, negative 16, 653.13. Okay, so if we solve this one, let me use a calculator. Wait, fx. Let me use my calculator. Sorry for medyo not ano. Okay, so let's use a calculator. Negative 2267.74 minus this one, negative 54.73. Okay, over 26.78. Okay, so the negative I have inputted it on the upper side. Wait, this one. Okay, then multiplied by negative, okay, negative 6.53.13. Then our answer is that negative 3,600, 36,000, I mean negative 36,301. Okay, so I will input it here. Sorry. Okay, so this is negative 301.56. Okay, that one. Okay, so okay, so that's it. Wait, if I have, okay, so that one. Sorry, this is 11. Sorry, this is 11. Okay. Now, as you can see, there might be differences because this is a big number. Then 2267.74. There is the factor of rounding up, or the conversions. I mean the rounding up values here affects the result. So that's why we are not able to get the exact one. But I guess this is just okay. So this is just nearly on our value, 301, which is 309. Okay. Um, if we continue the process, okay, and we want to get on the 8th row and 9th column, so the same process as what we have done it here. So it is shown in this code. then we get this result. Okay, then continue up here. Okay, then we get this result. Then continue the process up to n to 1. Okay, when k at 1, then we get it here. Okay. Okay, so that is the process of the backward elimination. Now after this one, we are not done yet. Okay, so since we have values in the coefficient, okay, so we need to divide here by its coefficient here. So to do that, we will use the code of normalization. Okay, sorry, normalization. Wait, normalization. So here. Okay, so um, initially our result is this one, but we have to make this coefficient equal to positive 1. So if there is a negative, we will transfer it here. So we need to make a code which is what we call normalization, and it is presented here. Okay, so for I is 1 to n, for example, for I is 1, so for 1 to 1, so first row, this is 4. Then for B is AII. So for AII, that is 4. For J, here 1 to n plus 1. So AIJ, so that is we divide all terms here by 4. Leaving that AIJ, so this is negative 213 over 4. Okay, so negative 213 over 4, if we calculate that one. Okay, so negative 213.02 over 4, then we get the value of negative 53.26. So it's here. Wait, yeah, here. So if we continue this process, we get this result. Okay, and this is our final answer. Now after this one, we need to make a code again to display what has the code done. Okay, so since we need to output the result in the present worksheet, so here is our worksheet. So we need to input the result here. I need to I need to make a code to input the result here. So I have it done it here, the display mode, the display command. Okay, so for I is 1 to n, so from 1 to 10. For J, 1 to 11. So the result will will go in this one. Okay, so let's go here and our command. So here the display is 1 to n. Then for J is 1 to 11. Okay, so the result will write on I 1 to 17. So where is that? When I is 1, so ith row is on this one, 18th. Okay, so this is the first one. Then up to up to 10. So up to 10. Okay, so this is 17 plus 10 up to 27. So here, then same as this one, this is 11. Okay, then yeah, that's it. If we run that one, this is how our program works. Okay, and that's how to make this one. Okay, and when it comes to the application of this program, how do we apply this one? Where do we apply this one? Is that there are we already use this method on finite element, solving matrix, no? Finding the inverse one. Okay, the inverse matrix, which is through Gauss-Jordan Elimination method also. Then we have also the advanced actual using stiffness matrix, stiffness method, using matrix. Then on the finite element, the linear strain triangle, the constant strain triangle, solving the coefficient of the parametric equations. I forgot the exact term, but we use this finding the value of the coefficients. Okay, so we use a Gauss-Jordan elimination method, and of course in reality in business, no, we always use this one about finding the number of income, or the number of outputs from the sold technology, or I mean the equipment, or and so on. Okay, so there are so many applications of linear equations, no, system of linear equations, and we can you can use this one, no? Up to 10 by 10 only. Okay, the limitation is up to 10 by 10 equation. Okay, so if there is no I have already done my presentation, so I hope you like my presentation, and I hope you learn something from this one. Okay, so thank you and goodbye.